Okay, so question 5, we've been told that y is a function of sine and cos that we've got over here in terms of theta. All it wants us to do is to differentiate it and make it look like this. Let's not think about this too much, let's just start off by differentiating this. So we can clearly see that u is going to be 3 sine theta and v is going to be 2 sine theta plus 2 cos theta. Sorry, I'm obviously going to pick these things out here because I'm going to intend on using the quotient rule. When I differentiate u, I get 3 cos theta. When I differentiate v, I get 2 cos theta minus 2 sine theta. And just a reminder of the quotient rule, we will have that dy by d theta here will be vuv, vu dash minus uv dash all over v squared. So dy by d theta will be v multiplied by u dash minus u multiplied by v dash all over v squared. So it was those two minus those two. Okay, let's just expand and start tidying up. So I've got these two expanding. You get 6 sine theta cos theta plus 6 cos squared theta. Now I've got these bits. Minus 6 sine theta cos theta plus 6 sine squared theta. Immediately you should see that this and this are going to cancel out. And then on the bottom, when I expand this, I get 4 sine squared theta plus 2, well, it might be helpful. Some people like to see it like this. Some people like to write out in a different colour. I don't know, 2 sine theta plus 2 cos theta multiplied by 2 sine theta plus 2 cos theta. So you can see you get your 4 sine squared theta plus your 4 sine theta cos theta plus another 4 sine theta cos theta, which is 8 sine theta cos theta, plus these two will give you your 4 cos squared theta. Okay, so we're nearly there. We just said that these two here and here are going to cancel, so you've got left with 6 cos squared theta plus 6 sine squared theta all over 4 sine squared theta plus 4 cos squared theta. Why do you think I've put those next to each other? Plus 8 sine theta cos theta. Now you should recognise this is just 6 lots of cos squared plus sine squared, and cos squared plus sine squared is 1. So this is just 6. 4 sine squared plus 4 cos squared is 4 lots of sine squared plus cos squared, and we know sine squared plus cos squared is 1, so it's just 4. And then we've got 8 sine theta cos theta. Well, that looks like 4 times 2 sine theta cos theta, which is the same as, using our double angle formula, sine 2 theta. So we're really nearly there. The thing that we wanted to make it look like was a over 1 plus sine 2 theta. Well, these can't be here, so we need to make sure we divide the top by 4 and divide the bottom by 4. So we end up with 6 divided by 4 on the top, and then 1 plus sine 2 theta that we've got here, which is the same as 3 over 2, 1 plus sine 2 theta. So the value of a that we were looking for was 3 over 2. Okay. Only thing you need to spot, this bit here, double angle formula takes you across to sine 2 theta. Okay. Question 6. This is year 1 content, so it shouldn't be too difficult. It says the circle has centre A with coordinates 7, 5. As soon as I've got that, I want to put on my diagram that this is 7, 5. The line with equation y equals 2x plus 1 is the tangent to C at the point P as shown in figure 3. I want to find out what this point P is, I imagine. Show that an equation of the line PA, so we're trying to find an equation of the line PA is this. Let's just add that onto our diagram for a second. We're trying to find out what the line PA is. So in order to do that, I need to know 2 things for this. I need to know its gradient, and I need to know a point that it passes through. Well, the gradient should be something I can find really quickly because I know these 2 lines here are at right angles to each other. And this equation here is y equals 2x plus 1. So its gradient is 2. So for our line PA, we know that its gradient is going to be the negative reciprocal of 2, which is minus a half. I guess I now need to find out a point that it goes through. Well, it seems to be going through this point here. So this is my gradient. This is my point that it's going through. This is my x1. This is my y1. So I'm going to use y minus y1 equals m brackets x minus x1. And very quickly, we hope it's going to produce us this thing that we've got. So that's y minus 5 equals minus a half x minus 7. I'm going to double everything to get rid of this. So that's 2y minus 10 equals minus x minus 7. So that's 2y minus 10 equals minus x plus 7. Let's get it in the form that they want. So we're going to add the x. So that's 2y plus x. And I'm going to add the 10. So I get 2y plus x is 17 for that first bit. Okay, so we've now got an equation for that line. It now wants us to find out an equation for C. Okay, so if we're going to try and find out an equation for C, I need to know two different things to find an equation for circles. I need to know the centre and I need to know the radius. If I have those two things, I can find an equation. Well, for the circle, we can already see that the centre is 7, 5, so I've dealt with that bit. The radius, I need to find the distance between P and A. I need to find the length PA. Well, I already know that the coordinate A is 7, 5, so I need to find out what P is. So I'm going to find P, then I'm going to find the distance PA. The way that you should be able to find the coordinate of P is it's the intersection of those two lines. So the two lines that we've got are y equals 2x plus 1. This is now for part B of the question. We're going to do the simultaneous equations with y equals 2x plus 1 and 2y plus x equals 17. The solution will be where they intersect, which is P. So I'm going to substitute this in here. So that's 2 lots of 2x plus 1 plus x is equal to 17. So 4x plus 2 plus x equals 17. So 5x is 15 and x is 3. Now if x is 3, we can use this to find out that y is equal to 2 times 3 plus 1, which is 7. So that must mean the coordinate is 3, 7 for P. Now, remember what our strategy is that we've got here. We're going to try and say, let's find out the radius PA. Let's find out the radius by doing PA. So we're going to find P and then the distance PA. Well, if this is P, we know that A is 7, 5, so we're going to find the distance between P and A, the distance PA. And we do that by doing the difference between these, which is 4 squared, the difference between these, which is 2 squared, so that's the square root of 20. So the radius is the square root of 20. Putting that all together, the equation for the circle, which has centre 7, 5 and radius root 20, it will be x minus 7 squared plus y minus 5 squared equals the radius squared. We then got to a slightly more challenging question for part C. It says the line with equation y equals 2x plus k, where k cannot be equal to 1, is also a tangent to C. Find the value of the constant k. So the reason that they've said that k can't be equal to 1, because you would have y equals 2x plus 1, which is this line that we've got here. Something we should notice is that the other line we're dealing with still has gradient 2. So the only place that this one can actually be is on this side of the circle. Now we can tell that this line has got to have a gradient of 2 because of this thing that we've got. There are a few different ways that you could do this question. I'm going to suggest this kind of way because it's the kind of way I'd like you to think about this. Once you've got the diagram drawn, you can see we've got the equation of the line. I just need to know a point that it passes through. So I know how to get from P to A, so I should be able to figure out what this point is. Now, the coordinates of P, we just worked out, and we said the coordinates of P if I just quickly scroll down here, we said that P was, where have I got that? P is 3, 7. Okay, so that must mean the x coordinate here is 3 and the y coordinate is 7. Pretty easily, just with some sort of deduction here, we can see what this coordinate must be, because this pathway is the same as this pathway. Thinking about it as vectors, to go from here to here is the same as to go from here to here. So if this is 3 and this is 7, it's gone along 4, so it's going to go along another 4. And this has gone from 7 down to 5, so it must go down another 2 to 3. So this coordinate here is 11, 3. So our line that we've got for part C goes through 11, 3. So we know y equals 2x, y equals 2x plus k. We can tell it's going to go through the point 11, 3. So we can say 3 equals 2 times 11 plus k. So 3 equals 22 plus k. So k is equal to minus 19. There is another way you could do this question, which I'm going to just talk about now. You could have said that the equation is a tangent. So you could have made simultaneous equations between your equation of the circle and the line 2x plus k. You could have found the solution to that, and then you could have done b squared minus 4ac equals 0 and found out the value of k from that. You should have come up that k is either 1 or minus 19. Obviously we reject 1 because it's told us that 1 is from this particular part of the question where we already know that's one of the tangents. So this is definitely the better way of doing this question, but as I've just said, if you wanted to, you could do simultaneous equations with this and this. You could come up with a quadratic. You could do b squared minus 4ac equals 0. You could solve that equation. You'll find out that k is equal to 1 or k is equal to minus 19, and we pick this one. But it's a lot longer. Okay, this is a lot longer method. Okay, next question. This one, we actually probably would be able to do this now. So if you're in my group, this is interesting for you to have a look at. We're going to integrate this particular function between k and 3k, and we're trying to show that it's independent of k. This will mean that the answer has not got k in it. It means it doesn't matter what k is, you're never going to get k in the answer. So we're going to integrate between k and 3k, 2 over 3x minus k with respect to x. So from our integration that we've got here, looks like this is going to be something to do with an ln of 3x minus k. If we consider ln of 3x minus k, then when we differentiate that, we get 3 ln of 3x minus k. But we don't want 3, so we're going to divide it by 3 and times it by 2. So we're going to scale it by multiplying it by 2/3. If we divide this by 3 and then multiply it by 2, we should come up with, it doesn't differentiate to that, does it? It differentiates to, my apologies, it differentiates to 3 over 3x minus k. So if we want to actually get this thing, we divide it by 3, so we get 1 over 3x minus k, and then we're going to multiply it by 2, so we get 2 over 3x minus k. So we need to add here a scaling bit of 2 over 3. And I don't need to have a constant because I've got some limits that we've got here, and it's between k and 3k. So I'm going to start off by substituting in 3k in place of x. So that's 2 over 3 ln of 3k times 3, so that's 9k minus k. And I'm now going to subtract 2 over 3 ln of putting k in here, that's 3k minus k. And actually, because k is a positive integer, I don't really need these modular signs anymore. So I have 2 over 3 ln 8k minus 2 over 3 ln of 2k. So I can take a factor of 2 over 3 out. That's ln of 8k minus ln of 2k. And by log laws, we know that this is the same as the ln of 8k over 2k. The k's are going to cancel, and you get 8 over 2, which is 4. So you get 2 over 3 ln 4, and you can say this is independent of k, because there's no k in the answer that we've got for that one. The second thing is we're going to say that it's inversely proportional to k. So in our answer, we want our answer to have something which is 1 over k. Something over k means that it's an inversely proportional to k. Okay, so going between k and 2k of 2 over 2x minus k squared. So let's see if I can just squeeze that in. I always forget to label which bits of the question I'm looking at. So we're going to go from k to 2k of 2 over 2x minus k squared with respect to x. Now the temptation here is probably to do a log, but actually it's not going to be a log. It's going to be a reverse chain rule, not reverse chain rule. I guess it's just going to be like a scaling kind of question, isn't it? So if we're going to scale this, what we would consider, we think the thing it's going to integrate to will be this thing, with the power raised up to -1. So we think it's going to be a 2x minus k to the minus 2. Silly me. To the -1. So let's differentiate that and see what we would get. We would get minus from the power, and then 2 from in here, 2x minus k to the -2. So it's almost right, apart from we've got this extra minus here. So when we scale it, we're going to have to put in an extra minus outside the front. So it's going to be like this, but with a minus. So this actually integrates to minus 2x minus k to the -1, all between k and 2k. I don't really like having it in this form, so I'm going to want to change this to -1 over 2x minus k between k and 2k here. I'm going to just start substituting in. So in place of x, I'm going to put 2k. So I get -1 over 4k minus k. Now I'm going to do that, subtract k in place of this, -1 over 2k minus k. So we have -1 over 3k plus 1 over k. Let's make this one have a common denominator. So we've got 3 over 3k minus 1 over 3k, which is 2 over 3k. If we wanted to, we could write that that's 2/3 over k, and then we just need a sentence to say, so this is inversely proportional to k. Okay, we end up with that k on the bottom, because if you remember at the beginning, what we tried to say here is that this is inversely proportional to k. Quite a lot of work there to come up with just those 3 marks. It's all for that integration that we've got there. We will do question 8 as well, and then we'll take a little break. So the depth of water, d meters in a harbour on a particular day, is modelled by the formula d equals 5 plus 2 sine of 30t. Look at this. It's got a degrees sign. Many of you forgot that actually this was a degrees question. You had your calculators in radians mode, where t is the number of hours after midnight. Hours after midnight. A boat enters the harbour at 6:30 a.m. Immediately you should think, well, that's when t is 6.5. And it takes 2 hours to load its cargo. So the cargo will have been loaded at 8:30 a.m. In other words, when t is equal to 8.5, that's how long it's going to be in loading for. The boat requires the depth of water to be at least 3.8 meters before it can leave the harbour. So it can't leave if it's below 3.8 meters. 1 mark question says find the depth of the water in the harbour when the boat enters the harbour. It doesn't say at the beginning of the model, so we're not talking about t being equal to 0 here. We're actually just talking about when t is equal to 6.5. So the depth is 5 plus 2 sine of 30 times 6.5. You must make sure that your calculator is in degrees here. So that's 5. Whoops, I'm not even in degrees after me saying all of that. So that's 5 plus 2 sine 30 times 6.5, and you come up with 4.48 meters to 3 significant figures. If you didn't include the meters here, you don't get that mark, because in the context of this question, it's asking for the depth. What is this 4.48? Is it 4.48 centimeters? Is it 4.48 kilometers? You need to make sure you're communicating that. Part B says, find to the nearest minute the earliest time the boat can leave the harbour. So I want to find out when is the depth of the water 3.8. But remember, T must be greater than 8.5. It has to be bigger than 8.5 because when it's smaller than 8.5, well, if it's smaller than 6.5, the boat hasn't even arrived. If it's between 6.5 and 8.5, then the boat is still being loaded and it can't leave the harbour. So I'm going to find out when the depth is 3.8. So I'm going to say that 3.8 in place of depth is 5 plus 2 sine of 30t. So I'll do my 3.8, I'll minus 5 and I'll divide by 2. So I get minus 3/5 is equal to the sine of 30t, okay? Now this is a degrees question, so we're going to think about how we solve this equation. So I'll do inverse sine of minus 3/5, and I get that 30t is equal to minus 36.869 blah 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 degrees. Now you've got to just remind yourself about how you would find the other one. So it's going to be, I think the pattern that we always use is that it's 180 minus this, or you can think about your cast diagram. We've just got minus 36 degrees over here, so that's why it's come down. The other place where it would give you a negative would be over here. So if I do 180 minus this, I'm predicting I'm going to get a larger angle bigger than 180. So when I do 180 minus this, your second one should be 216.869 degrees. Now you've got these two things here. If we need to, we can plus 360 to this, and we can plus 360 to this. But let's just find out if our t value is going to be good. Well, there's no point in dividing this one by 30, because I know that it's not going to be bigger than 8.5. Let's just divide this one by 30 and see what we get. Well, for this one, when you divide it by 30, you get 7.2289, but this one is not going to be good. So I'm instead going to take this one and I'm going to add 360 to it and see what that gives us. So let's just go back. Let's times that by 30 and we'll do 180 minus the answer again. So I'm going to add 360. Looks like the next solution we've got here is 323.13 blah 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 degrees. I'm just going to divide that by 30 and see what we get. Okay, when I divide that one by 30, I get 10.77100. Great. That's the first one that's going to be bigger than 8.5. So this is the value of time that I'm looking for. Again, I think I've mentioned this in one of the other videos. There's a button on your calculator that will automatically change this. So we've got this button with the commas like this. If you press this, it will change it into hours and minutes. So it should come up on your calculator as something like 10 hours, 46 minutes and 15 seconds. And it wants it to the nearest minute. So it's going to be 10 hours and 46 minutes after midnight, which is going to be 10:46 a.m. for the time that you've got there, okay? This is the mistake that lots of people made. They forgot that you're going to have to keep finding more values of time for the trig. You have to add on the 360 and stuff before you divide by 30. You can't do that afterwards.